Hey, what's up? I'm Dave Boyer, aka Mr. Boyer, aka the Swamp Man. I'm here at my own property. This is Boyer's Park. A lot of students at the start of the school year have been asking me about it since they've seen it on my haiku page, saying, "Is that really your house?" Yeah, this is my house. I haven't been living in it for a couple of months now, since May 18th actually. We moved out because we had an addition put on. Still in the process of that. We just got siding up. Hasn't been painted yet. It's not going to stay that color. We've picked out a color called Deep Ocean. Should be pretty cool. It's going to really change the look of the house after it gets painted. But it's a pretty neat house, pretty neat property I have here. Got 81 acres that I play around on, lots of trails that I go hiking on. But I thought I'd kind of take a moment here today to talk to you about the Earth itself. Every planet has some really cool things about it. Saturn has those rings that everybody thinks are really beautiful and spectacular. Jupiter has that giant spot on it that's actually a storm that's been raging on that planet for a really long time. Each planet is kind of unique and special, but Earth tops them all. Earth is by far the most unique and special because it supports life, and none of the other planets that we found have we found evidence that they support life or can support life even. Mars being kind of close. Mars has some good things to it. Mars has some features that make it look like possibly it could have had life at one time on there, but certainly it doesn't seem like it had life like Earth does. So what makes Earth so special? Well, there's tons of stuff that makes Earth so special and make it support life here. But what we're going to be studying this week in science is the electromagnetic spectrum. So I thought I'd kind of share a little bit about that. It's a cloudy day. We don't have a good look at the sun out there, but everybody's seen the sun here on Earth, from Earth. Sun being 93 million miles away or so, and it's constant explosions, doing nuclear fusion, slamming hydrogen atoms together, and releasing a whole lot of energy off into space at the same time. Well, that energy leaves the sun in the form of light waves, and there are many different types of light waves that are leaving the sun and heading towards Earth. And all of those waves get put on this spectrum, this line, this range of light called the electromagnetic spectrum. And it goes from waves that have really long wavelengths, like radio waves, all the way down to waves that have very, 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 very small wavelengths, called gamma rays. Well, each of those types of light coming off of the sun have different things about them that can make them either harmful or beneficial for here on Earth. So I'm going to talk about the harmful ones first. Gamma rays. The shorter the wavelength is, the higher the frequency that wave has, the more energy it has and the more potentially dangerous it can be. If gamma rays were to hit us as humans, it would cause mutations and cancers of our cells and ultimately wipe out life on Earth if gamma rays were to strike the Earth. Well, gamma rays are coming at the Earth. They're trying to get to the Earth. They're leaving the sun. They go off in all directions away from the sun. But as they approach the Earth is protected by an invisible force field around it. It sounds kind of crazy. Sounds like a movie, but it's real. Earth has a magnetic field. So the center of the Earth, the core of the Earth, has this solid metal ball, this solid metal sphere of iron and nickel, and it's surrounded by this liquid metal of iron and nickel. And the rubbing of those two metals against each other, the outer core and the inner core, creates magnetism for Earth, this magnetic field that connects the North Pole and the South Pole and sends off all this protective energy around the Earth. And as the gamma rays and some other wavelengths that we're going to be talking about, some other parts of the electromagnetic spectrum like X-rays, so when the gamma rays and X-rays are trying to strike the Earth, they are deflected away by Earth's magnetic field. A really important thing that helps protect Earth and make life here on Earth possible. For planets that don't have a magnetic field, like say Venus, and Mercury, those planets are bombarded by the gamma rays, and they would wipe out any life that could be there. Well, it's not just the gamma rays and X-rays that could be potentially harmful for life here on Earth. There's also ultraviolet rays, ultraviolet light. You've probably heard about that. You've probably put on sunscreen, I hope, in the summer to protect you from UVA and UVB, ultraviolet light. the ones that cause sunburns, and they actually can cause skin cancers as well. But up in the atmosphere, we've got different gases that are there to help protect us. And in particular, there's one layer of gases up at the top of the stratosphere called the ozone layer. And the ozone layer is made up of ozone molecules, O3 molecules. And those ozone molecules are blocking out all or most of all of the harmful ultraviolet light from getting down to the Earth's surface. If it wasn't for that ozone layer, humans would get skin cancers at a much, much higher rate. We would have deaths from skin cancers, and humans aren't the only ones. Animals all can be affected by UV rays. So those two things, the Earth's magnetic field and the ozone layer, are the two key protections for Earth that make life possible, that keep us protected from the dangerous light coming in the form of different parts of the electromagnetic spectrum, like gamma rays and X-rays. We also have visible light. Visible light's the middle of the electromagnetic spectrum, and it's not that harmful, but on a day like today, if you're looking around at the mountains back there, can't even see them because they're shrouded in clouds. I usually have a really nice view of Hanging Rock back there. But clouds can help to protect us from some of the visible light. It would make things hotter here on Earth if all that light were able to reach the surface. It may be too hot for humans to be here. So we got some protections for us. A lot of the parts of the electromagnetic spectrum are not harmful at all. Radio waves, you get hit by radio waves all the time. I've got a cell phone in my pocket that's probably communicating right now with using radio waves with cell phone towers or cell phone satellites up in space, and they don't harm us. Microwaves, you cook your food in the microwave, which uses microwave radiation, a type of light from the electromagnetic spectrum to cook the food, and it's harmless for humans. Infrared is just basically the heat signatures of light. It's the form of light that can be converted into heat really easily, and it's harmless. So different parts of the electromagnetic spectrum have different properties to them. Some of them can be really beneficial. We'll study a lot of that. Some of them can be harmful, like I said, with the gamma rays and the X-rays. But luckily, Earth is a unique and special planet. It's our planet, and it's here to help save us and make life possible. A little bit of a long video talking about that kind of stuff, but I can't wait to share a lot more about the electromagnetic spectrum in class. And I'm about to get off and try to help clean up a little bit from after our construction going on here. Just wanted to stop and share that with you and tell you that science rocks. Peace.